All right, so we're now going to answer part B of this question, which says 2 marbles are now selected at random without replacement. So now instead of drawing 3 marbles as we were in part A, we're now just drawing 2 marbles out. And also there isn't any replacement going on here. Now it says how many different possible combinations of colors could be selected. So let's think about this. You could pull out a red and a red and a blue, or a red and a green. Or you could pull out a blue and a blue and a red, or a blue and a green. Or you could pull out a green and a green and a blue, or a green and a red. Now, take note that we want different possible combinations here. So that means we don't want any of them repeating. And let me just also add here, for your specific exam, because we're not dealing with combinations, that will be something we see in semester 2. You're most likely not going to come across a question. Let me say that a bit. You're not going to come across this in your actual exam. Combinations will be saved until semester 2. So you're not really going to get a question like this. In semester 2, we'll learn that combinations mean when there aren't any doubles. So a combination means that you can have a red and a blue, but blue and a red, that's the same thing. So that means we get rid of one of them. So too here, like you can have a red and a green, but that's the same as the green and the red. So you're going to get rid of one of them. You've got a blue and a green, but you have a green and a blue. So you get rid of one of them. Now, these are the different possible combinations. So the order doesn't matter. All right, so that means we've got 1, 2, 3, 4, 5, 6. So that means you've got 6 different ones. So equals 6 here. And again, you're not going to come across a question like that. Okay, next, what is the probability of selecting 2 green marbles? 2 green marbles. Okay, so let's think about this. The probability of a green and then a green. Well, if we know that there are 3 greens out of a possible amount of 12, and then we're also not replacing it. So once we've selected 1 green, that means there's 1 less, and there's also 1 less in total. And that means we're going to get 1 on 22 there. What's the probability of selecting 2 marbles of the same color? So 2 marbles of the same color. Probability 2 same color. What's this going to be? Well, hopefully you can see what that's going to be is the probability of green, green, plus the probability of red, red, plus the probability, if I could spell, the probability of blue, blue. Now, we already know one of them. We already know 1 on 22 is green, green. So now we're just going to repeat that process. So to find red, red, well, how many reds are there? So how many reds are there? This is where I'm going to have to remember. I don't remember how many reds. There were 4 reds, 4 red marbles. So that means it's going to be 4 on 12 times 3 on 11. So you always have to make sure to reduce it. Blue, blues, how many blues were there? I can't remember. There were 5 blues. So that means you're going to get 5 on 12 times 4 on 11. And now you're going to do that. So we're going to come here. We already knew one of them. Control this. One was 1 on 22. Then you're going to times this. Whoopsie daisy. Control divide. It's going to be 4 on 12 times 3 on 11, close the brackets, plus, whoops, I didn't put a plus there. And then you're going to go again to the last one here is going to be 5 and 4, hit enter. It's going to be 19 on 66. So it will be 19 on 66. All right, I really need to stick to one color here. I'm kind of going all over the shop on my colors. 19 on 66, 1 on 22, and 6. All right, the next one. What's the probability of selecting 2 marbles of different colors? Okay, this is where I really think you need to turn your brain on a little bit and think, all right, well, I know that the probability of selecting 2 marbles of the same color is 19 on 66. So the probability of selecting 2 marbles of a different color is simply going to be 1 minus this right here. So this is recognizing that these are complementary events. selecting two of the same color. What's the opposite of selecting two of the same color? Well, it's going to be selecting two marbles of different colors. There are no other options here. So that means to answer this question, all we're going to do is we're going to say it is 1 minus the probability of two of the same color. So it's going to be 1 minus 19 on 66. And then once you put that into your calculator, 1 minus 19 on 66, you're going to end up with 47 on 66. So again, you're just going 1 minus, and you could just come up here, bang, 47 on 66, just like that. That's the best way to do this. Now, there is another way to do this, and instead of writing it out, let me just show you this. So this question was taken from NEEP, I think from the 2020 exam. As you can see, we've used this option right here. Alternatively, you could say, well, what's the probability of red, blue, blue, red, red, green, red, green, red, green, blue, blue, green. So you're taking all of them, you're multiplying them all, and then adding them up. Do you see how it's so much quicker you're doing it this way? You'd burn a lot of time doing it the alternative way. So always make sure you're thinking through the best way to do things. All right, the last question of this part is saying, if the first marble selected is green, what's the probability that the second marble selected is green? So this is recognizing that this is a conditional probability question. So what it's saying is, what's the probability that the second is green, given that the first is green? So that means we're going to go, well, what's the probability of pulling out two greens? So green intersection of green over the probability of the second is green. So the first marble is select. So this is where you gotta be careful. Let me just write it out fully. So if the second is green, intersecting of the first is green over the probability that the first is green. Okay, this top part right here, let me highlight it. All that's saying is, what's the probability second green intersection of first green? That's just the same as what's the probability of green than a green. And we've already figured that out. That was 1 on 22. So this is where it's really utilizing what we've done previously. So you don't have to figure that out again. There it is, 1 on 22. Then what's the probability that the first one that you're going to get out is a green? So what's the probability the first one is a green? Well, you know that the probability the first one is a green is 3 on 12. So we can come on here and we can go 3 on 12. And now it's just a matter of chucking this into our calculator. So we can come here, and do I have 1 on 22 here? I don't. All right, that's okay. So control divide 1 on 22 over control divide 3 on 12. So it will be 2 on 11 as my final answer. 2 on 11, that's it. And we're done. That's how you do that question there. So just make sure you're thinking through your questions in order to be successful. All right, I'll see you in the next one.